Hey, welcome to the Explainer. You know that glass of water you might be drinking right now? Well, its story is literally billions of years old. Today we're going to follow just one single water molecule on its incredible, nonstop journey through time. Let's dive in.
So let's just kick things off with a pretty wild question. Is it possible that the very same water you're drinking was once lapped up by, say, a T-Rex? The answer is, well, it's pretty mind-blowing. To get to the bottom of this, we're going to shrink ourselves down, way down, and tag along with one little water molecule as it travels through the single greatest recycling program on the planet, the water cycle. All right, so the first leg of our molecule's adventure is all about escape. A great escape, actually, heading straight up into the sky. It all begins with our sun. Its powerful energy beams down and hits the surface of a lake, giving our water molecule just the jolt of energy it needs to break free from all its liquid bodies and float up as an invisible gas we call water vapor. And that process, that transformation from a liquid into a gas, has a name: evaporation. It's the very first step in our molecule's big trip from the ground up into the atmosphere. But hold on, there's actually a shortcut. If our molecule is, say, frozen solid on a snowy mountaintop, it can skip the whole melting part and just leap directly from a solid ice crystal straight into the air as a gas. This really cool trick is called sublimation. You can think of it as the express elevator for water molecules, going directly from the solid floor to the gas penthouse, no stops in between. So our molecule is now a gas, floating high above the Earth. So what's next? Well, now it's time to find some friends and build something truly amazing: a cloud. See, as our molecule rises higher and higher, things start to get pretty chilly. That cold air saps its energy, making it slow way down and start to huddle together with trillions, and I mean trillions, of other water vapor molecules. This whole huddling process, where the gas turns back into a tiny liquid droplet, that's called condensation. And when that happens on an absolutely massive scale, well, that's how you get a cloud. And what's really cool is you can actually see this happen with a simple experiment at home. In a cloud in a bottle, you add pressure and then suddenly release it. The temperature inside just plummets. This super fast cooling forces all that invisible water vapor to grab onto tiny smoke particles, and poof, you get a miniature cloud right there in front of your eyes. Okay, so our molecule has made it up into the clouds. But you know the saying, what goes up must come down. The next part of its journey is the long fall back home to Earth. Inside that cloud, our little droplet starts bumping into other droplets. They merge, they grow, getting bigger and bigger and bigger, and eventually our droplet just gets so heavy that the air can't hold it up anymore. And down it comes. We call this precipitation. Now, depending on how cold it is up there, it could be a gentle rain, a perfect little snowflake, or even a hard chunk of hail. So after our molecule lands, it might try to soak into the ground. But what if the ground is already totally saturated? You know, like a sponge that just can't hold another drop. Well, then it has no choice but to start flowing right over the surface. This flow is what we call runoff. It's how our water molecule basically hitches a ride in streams and rivers, which eventually carry it all the way back to a bigger body of water, like a lake or the ocean, ready to start the whole cycle over again. Hey, remember that shortcut from before, sublimation? Well, guess what? It works in reverse too. On a really cold, clear night, water vapor floating in the air can completely skip being a liquid and turn directly into solid ice the second it touches a cold surface, like a blade of grass. You know that beautiful, delicate frost you see on a chilly morning? That's it. That's deposition. It's the final phase change trick in our molecule's playbook, going straight from a gas to a solid. But, this cycle isn't always a super fast loop. Sometimes our molecule decides to take a break, and sometimes that break can be a very, very long one inside one of Earth's giant water storage units. I want you to think of the Earth as having these enormous water tanks, or reservoirs, and they're not always where you'd expect. Sure, there's water on the surface in oceans and ice caps, and in the atmosphere as clouds. But there are also vast quantities of it hidden deep, deep underground. And the scale we're talking about here is just immense. A staggering 97% of all the water on our entire planet is saltwater, locked away in the oceans.
That really puts into perspective how incredibly rare and vital that little bit of remaining freshwater is for all life on land. So that tiny fraction of freshwater is unbelievably precious. Our molecule might end up frozen inside a massive, slow-moving glacier for centuries. Or maybe it'll just flow down a river for a few weeks, or simply hang out in a lake for a couple of years. Or it could seep deep down into the earth and become part of something called an aquifer. And let me tell you, this is no short layover. Once it's trapped in these huge underground layers of rock and sand, our little molecule could stay there for hundreds or even thousands of years before it ever rejoins the cycle. So from the belly of a dinosaur to the heart of a glacier, from a cloud in the sky to the cup in your hand, this single water molecule has really seen it all. Its journey never ever ends, which brings us right back to that first question. Did a dinosaur drink your water? Yeah, almost certainly. And now that its journey with us is over, for now, where do you think it's going to go next?